So last but not least, we have the differential operating characteristic, as you can see. And now we are going to test the dual slope characteristic for the differential, which is the most important dedicated module in our case. And we have two ways, as we explained. We have a search test and we have a shot test. So you can select some shots, or you can add some search lines. So I will make it in two ways for you to check how to select both ways. And here you have to define the fault type to be single line or double line or three line. And if you are going to the general tab, you will find the trigger condition, as we agreed to use the differential trip, the binary input one, to be the trigger condition. And here is the pre-fault if you need to add a pre-fault for some relay vendors. And here too, if you select this one, it will ignore the nominal characteristic, as you can see. So it will search not based on this relative or absolute tolerance. It will ignore the nominal characteristic, and it will give you the exact values. In case of you don't know the dual slope characteristic, it will give you the intersection point between the search line and the dual slope characteristic line to find the exact values. But now we have the complete setting of the relay, so I will not ignore the nominal characteristic, and I will assess the trip times and the Idiff values based on the tolerance. So for example, I will add some point in the slope 1 and some point also in the slope 2, and then I will start the test. As you can see now, once the test is running, you can compare between the Idiff nominal and the Idiff actual. So based on the equations and based on the relay manual equations, the Idiff nominal should be 0.3 when the Ibias equal to 1. And now the actual values is 0.296, and based on the relative and the absolute tolerance band, it's assessed as a pass. And the same for point at 2in of the Ibias and 3in of the Ibias, you will have different values of the Idiff nominal, and compared between the actual and the nominal value, it will be assessed as a pass or fail. And here is the tolerance band. If you see this dashed line, upper and lower dash lines, this defines the accepted tolerance band. So above these values or lower than the lower dash line, it will be assessed as a fail. Within this two band, which I think is 5% based on the relay protection manual, it will be assessed as a pass. So now the test is done, as you can see, between the high voltage and the low voltage for the single phase to ground L1 to earth with some test point. We can do the same also for the other fault types like 3 line or 2 line and many more. Or you can check the shot test. So you can select the characteristic, as you can see here, for the 3 line, and you can add only some shots, or you can add some search lines. So if you are removing all this search line, and you can add here some shots, so this points should be tripped, and the other points below the dual slope characteristic should be blocked. Just we do a quick check to find how to test this characteristic in both way. And as you see, if you are trying to put any value or any test point above the maximum torque angle, it will be not added because it's mathematically impossible, because this maximum torque angle or maximum torque line, it simulates and represents the maximum short circuit current can happen inside this protection zone and inside the power transformer. So it's not possible to simulate any value above this maximum torque line. And then you can select also the general tab to define the trigger with a differential binary input, and then you can select the start test, and you will have some values. As you can see here, the expected is no trip because it's below the line and it's below the dual slope characteristic. So you can check. Here is no trip, and the T actual is no trip, which means it's expecting there is no trip because it's below the dual slope, and the differential not trip. which means it's in the blocking zone. And the other values, which is above the curve, it's tripped with actual trip time 0.029, which means 29 milliseconds. So there is two ways to check this dual slope characteristic. And now we finished the high voltage and the low voltage dedicated test modules for checking the differential, but we can take one more for the fifth harmonic, as we test only the second harmonic. Just the only difference in these values, we can remove some point to make the test is quicker. So we will remove this point. And the only difference here, I will check this second harmonic to be fifth harmonic, which means at the 45%. So above this percentage, it will be in the blocked zone, and below this percentage, it will be in the tripping zone. And this fifth harmonic is used to check and simulate the superimposed waveform with 5 multiplied by the frequency. So if we have 60 hertz frequency, nominal frequency, in the nominal fundamental waveform, so we will superimpose a fifth harmonic waveform at 300 hertz to simulate the overexcitation and to check the blocking of the differential protection function against this kind of events. Then you can select here also the L1 to L2, L3 as a 3-line fold, and you can check the fifth harmonic blocking in this case. So the expecting nominal values as per setting, it will be 45, as you can see from this column, IXF over IDF nominal in percentage 45%. And now we are checking this characteristic, this actual values, as you can see here, compared to the nominal values, and it will be assessed as a pass or as a fail based on this tolerance band. So it takes a lot of times. So we can take this 2 point as a reference only. Just it will continue to inject the other 3 point